Hello, you're welcome to New Focus Approach to Mathematics Basic 9. This is the revised edition, and in this lesson, we want to learn how we can apply the rules we studied earlier. Now, our first example is this: simplify each of the following cells. Remember, we've learned the rules, so we're going to apply the rules. Here we have square root of 2 to the power 3 times square root of 5 to the power 2. Now, how do we simplify this? Remember, this is the same as root 2 squared times root 2, so that to give us root 2 to the power 3. Okay, then times root 5 also squared. We learned that square root always cancels square, and so here we'll be left with 2 times this will give us root 2 times here also the square will cancel the root, leaving us with just 5. Now we can multiply 2 and the 5 to give us 10, then we say root 2, and that becomes our answer. And so the simplification of this is 10 root 2. Now when you come to this part of the work, the B part, again we have 2 root 3 simply means we can say 2 root 3 squared times 2 root 3, so that we get back our 2 root 3 cube. Now 2 root 3, we square this and that will give us 4. When we square root 3, the root will cancel the square, so we left with 3. So that is the first part. Then times, here we have 2 root 3 as it is, we can leave it like that. Now we can now multiply 3 times 4, which is 12, and 12 times 2 will give you 24. Then we keep our root 3, and that becomes the answer. I hope it makes sense. Good. Let's take another example. Here we have to simplify this, and this is addition and subtraction of cells. So I have square root of 2, okay, plus this can be reduced to the lowest form as 2 root 2. Remember this. Beginning of the set, we learned about how to reduce cells to the lowest form. I said, so that's what we want to apply here. So root 8 is the same as 2 root 2, and root 50 also the same as 5 root 2, because it's going to give us root of 25 times root of 2, and so we get 5 root 2. Then minus 27 the same as root of 9 times root of 3, and that will give us just 3 root 3. Now we want to simplify this. Since this is root 2 and this is root 2 and this is root 2, we can now add them to say that here is 1 plus 2 making 3 plus 5 making 7, so 7 root 2. Okay, then minus 3 root 3. Now since root 2 and root 3 are not the same, we can add and subtract this one, so this becomes our answer. Good. Now let's take another example. This time we want to apply rationalization. Okay, and so this is the same as 10 root 2 divided by root 8. Now since I'm not adding, I can keep the root 8 without reducing it to the lowest form, so I can just keep it like that, or I can also reduce it to the lowest form if I want. But for now, let me just say this is the same as root 8 over root 8. Remember that whatever is here and whatever is here are the same, nothing has changed, because if I divide root 8 over root 8, I'll get 1, and 1 times whatever is here will give me just the same as what we see here. Okay, so now we can simplify. Now if I multiply the numerator, that is the 10 root 2 times root 8, I'm going to have 10 root 16, okay, because 2 times 8 is 16, or divided by root 8 times root 8 will just give me 8, like we said earlier. Now I can simplify this as 10 times 4 divided by 8, and of course I can still simplify this further as 4 times 10 will give us 40, and 40 divided by 8 will just give us 5. And so the simplification of this is 5. Right. Let's try the last one. Let's use the conjugate set here. So again, we can write the same thing as 2 over root of 3 plus root of 2. Then I multiply this by root of 3 minus root of 2 divided by root of 3 minus root of 2. So that is the conjugate aspect that we did earlier in our previous video. Now we can simplify this by multiplying the numerators and denominators. So the numerator, the 2 is multiplying the 3 here to give you 2 root 3, and the 2 here will multiply this also will give us negative 2 root 2, all divided by, now if you look at the denominator side, you can see difference of 2 squares here. And difference of 2 square, we know that if I have a plus b, a minus b, I can easily write it as a squared minus b squared. You understand? So the same thing applies to the denominator here too. So the denominator too can be expressed as root of 3 squared minus root of 2 squared. That's what it means. Okay, so I can square the 3 and square the 2, which will give me 3 minus 2. Right, so I can easily write this answer as 2 root 3 minus 2 root 2, all divided by 3 minus 2, which is 1. So finally, any number divided by 1 is the same as the number, so I can leave my answer as such. I'm sure this has really helped you in understanding how to apply the set identities in solving questions. Go ahead and solve more questions from the textbook, and I'm sure it will be of great help to you. Thanks so much for watching.